Hello friends, so hope you're all doing fine. This is Krish Naidu here. I'm speaking for Mathnal for the SEM Radio M YouTube channel. So today I'm here to discuss regarding the forecasting functions of Excel. So if I say Excel, it means Microsoft Excel, right? So we'll talk something about how to use forecasting functions in Excel sheet using a data. So I will take you to the data now and we'll take it from there. For that, I need to share the sheet. Okay. Okay. So I think you're able to see the screen. So I'll just share a few things about this data sheet. I'm having actually a sales data of e-commerce firm. I'm hiding the item description because that is not relevant here. So because this is a confidential data, so I would like to hide the item description of the client. So I will be showing the item code, and there is the second column contains the unit of measurement, right? And we have the sales data from Jan 19 to July 19. And what we will do, we will do the prediction for August 19. I'm going to use only a single month because I just want to show you how to use the forecast functions of Excel. Okay, so we'll not do forecasting for other months. And in case if you have any doubt or if you have any questions, you can write to my email ID krish@mathnal.com. The spelling of Mathnal is Mathnal, and the spelling of Krish is Krish, right? So you can write down for if you have any queries on how to use for multiple months. So I think it's very simple. We don't need to worry about whether you have to how to use multiple months forecasting. So you don't have to worry about that. So I will show you how to use the forecasting for 1 month. So now you're clear about what is the data, what kind of data we have. So we are trying to forecast for August 19, what will be the sales of August 19. So before that, what we want to understand is what are the functions we are going to use, right? So the formula which we are going to use is forecast.ets. So ETS stands for exponential triple smoothing. Exponential triple smoothing. So the triple smoothing word refers to three variables. One is the trend, second is the seasonality, and third is the base, right? Means the base means it is not having too much of variations. So that is something like we have a data which revolves around the average. That is a base. So we have three parameters. So we are trying to smoothing. We are going to smoothen all three variables, right? That is called triple smoothing. So if you want to understand more about triple smoothing, you will find plenty of content online. Or we also conduct training on triple smoothing or forecasting. So detailed forecasting training program also we have. We can join our training program also. So triple smoothing is, we are trying to smoothen three different variables. That is seasonality, second is trend, and third is the base part. Okay, using the smoothing constants alpha, beta, and gamma. Okay, that is called triple smoothing. So suppose if you have seasonality and trend and base, means if your data contains seasonality, it is going to be classified as we're going to use exponential triple smoothing. If data do not have smoothing or do not have seasonality, then what we are going to do is we're going to make seasonality is equal to 0, right? So this will become a double smoothing. Means it contains only trend and the alpha, or means the base. Okay, so that is called exponential triple difference between the exponential triple smoothing and double smoothing because we're trying to say that if there is seasonality, it is triple smoothing. If it is not having seasonality, then it's a double smoothing, right? That's the way you're going to use the formula, and the formula is forecast dot ETS. First, we'll take the target date. Second, we take the values, historical values. Third, we're going to take the time range. Time range is Jan. Here, in this case, we have the time range is Jan 19 to July 19. That's the time range we have. Okay. and then we'll take, do we have any missing values? And if you have the missing values, so are you going to, or do you want to replace those missing values? And if you want to replace the missing values, how are you going to replace those missing values, right? So missing values means if you want to replace the missing value with 0, or you want to replace the missing value with the average of the clustered group, which are closer to that particular missing value. So here I will take the missing value. It all depends upon you, the choice what you have. Generally, I want to keep my data original. I don't want to change anything over there. So I will keep my missing values as 0. For that, I have to put 0. Okay. And if you want to replace the missing values with the average of the clustered, near about clustered values, then you can put 1 over there. Okay. Then the last one is the aggregation. Suppose if you have, for January 19, you have multiple data points. Okay, January 19, you have multiple data points. So how you want to take, how you want to group them? You want to take the sum of the January 19 first data point to a second data point, or you want to take the average of them, you want to take the mean of them, you want to max of them, right? So for everything, you have a specific number: mean, max, count, sum, average. Okay, so I'm going to take average. So that is 1. So this is the formula which we have to take to calculate the forecast.ets. And sorry, I forgot one more thing, that is seasonality. Sorry, seasonality is one more aspect we have to put over there. So the target date is for which month we are forecasting. Historical values means the data which we are taking from which we are going to compute the average. Then the season, then the time range. So I'll put time range after. I'll put seasonality after time range. Okay. Then time range, as you have mentioned, what is time range? Time range is from Jan to July, what we are taking over here. Seasonality, whether the data has a seasonality. Seasonality we all understand. And if you want to understand more about seasonality, you can see some of the videos which we already posted on the YouTube or channel, SCM Radio M. 0, I have told that's if you have any missing values, whether you want to replace those missing value with 0, or you want to take the average of the near about clustered values around that 0. 1, the last one is the aggregation. Means you want, if you have for same time period multiple values, so how you're going to take those values? Means you want to take a sum of those two values, you want to take the average of those two values the same period, right? You want to take the min, max, count. So for every particular function we have a number. So 1, 2, 3, 4, 5, 6, 7, 8. So for what I'm taking here is the average. For average I'm going to take x 1. So this is how we are going to use the formula and the syntax of the formula. Okay, this is the syntax of the formula that we have to remember. I'm going to just wrap the text so that it is visible to you guys on that. Okay, so let's understand. So the first thing in forecasting is whether the data has a variability or do not have a variability. So what is the significance of the variability? If the data has a high variability or medium variability, then it is very difficult to forecast that. Okay, but if the data has a lower variability, it is easier to forecast. So how to understand whether the data has a variability or do not have the variability? So what we have to do that for that is, first we have to calculate the average sales. Okay, we have to calculate the average sales, and the formula for that is equal to average. Take the data range. This is the data range. This is an average. So right now there is a filter applied being on the data. So I will remove those filters so that we work on all the data sets for each and every item code. Okay, so I have removed the. So after average, we are going to compute the standard deviation. Okay, so what is standard deviation? I'll tell you the reasoning or the philosophical meaning of that. So I have a data point 206, 2016, and I also have the average 1440. So what is the gap between this data point and the average, right? The gap between them. So similarly, we will have a gap for each and every month sales with the average sales, right? So standard deviation is the net gap. Okay, that's the philosophical meaning. So how we compute standard deviation is a completely different exercise, which I'm not going to discuss over here. So So what you understood is the net gap between each and every value with the average. Okay, so here the gap between 2016 and 1440 means how are you going to find it? You're going to subtract 1008 and 1440. You're going to subtract. You get some value. That's a gap. Similarly, 1008 is the sales of the March 19. So average sale is 1440. So what you're going to do is you're going to compute the gap and gap between the sales of March 19 and average sales. Similarly, you're going to compute the gap between the sales of April 19 and average sales. So we'll end up at July. So we calculate the gap between the sales of July 19 and the average sales. So what you're going to do is, you're not going to take the gap of each and every month's sales to the average. You're going to compute the net gap, and that net gap is, or the average gap is 1408. That is the standard deviation. So what we are going to want to understand is whether this standard deviation is high or low. That is what we want to understand. Okay. So if lower the value of standard deviation, lower is the variability. Higher the value of standard deviation, higher is the variability. Okay. So so by looking at this number, what we want is the standard deviation should be lesser than the average sales. Okay. The standard deviation should be lesser than the average sales. That is what we want. Okay. If you want to understand the gap. Okay. So, or if you want to understand the variability. So the variability has to be lower in order to have an easy forecast. But if the variability is higher, means the forecasting will become complicated. So we need to use some different methods. So what we want is the standard deviation should be as low as possible. Okay, but is it how low or how high is not actually being understood with this number. For that, we are using a different metric called coefficient of variation. Okay, so that is a formula for this is you have to divide 14 standard deviation by the average and multiply that into 100. Okay, so here I will not multiply 100 because already I have applied a formula format is already ready. So here is 98%. So I'm going to drag this formula, so we'll get the answer. So what we want is this value to be closer to 0 in order to have and judge that we have a lower variability. If this value is closer to 100% or more than 100%, then we can assume that the variability is very high. So the simple forecasting formulas are not applicable because the coefficient of variation is higher or closer to 1 or more than 1. If the coefficient of variation is closer to 0, then we can say that the variability is lower. And if the variability is lower, then we can use a simple forecasting formulas like average and all, because we don't have to invest too much of complicated formulas and increase our time of solution. Okay, so this is the reason why we are trying to find the coefficient of variation, because we don't want to invest a lot of time on computing the forecasting. So if we have this lower variability closer to 0%, then we can use simple formulas of forecasting, right? I also computed variability quotient is simple like the difference between the average sales and standard deviation. Okay, and I have divided it with average sales. So we'll not go on this area, on this aspect. Okay, I'll not discuss this variability quotient over here. So just I gave the hint on how I have computed that. Now we have to understand whether there is seasonality in the data or not. How to compute using an Excel function. So that we have a formula called Forecast.ets.seasonality. Okay, a forecast. I'll write the formula for you. Forecast.ets.seasonality. This is a formula. Okay, I'm clicking over there, and I'm going to follow the formula. So values. What are the values here? The values are from Jan to July. Okay, comma. What is the next timeline? What is timeline here? Jan 19 to July 19. As this timeline will be repeated for different item codes, so I'm going to fix that or freeze that. Okay. Now timeline also we have done. Data completion. So if we want to replace the missing values with 0, then we'll put 0. If we want to replace the missing values with some average of the near about clustered value close to the missing value, then we'll put 1. So in this case, I'm going to keep the missing values as 0. So I'll put 0. Now the second one is aggregation. So if you have multiple data points for the same timestamp. Like for January, you have 3 data points. Okay, so what you're going to do with those 3 data points? Are you going to cluster them in the form of average? Are you going to cluster them in the form of sum? Are you going to take the minimum value, maximum value? So you have to decide some number for that. So there is various numbers for that. So I'm going to take the average. So I'm put 1 over there. Okay, this is the formula. So what is the answer or outcome? The outcome is 2. 2 means the seasonality is for 2 months, right? So I'm going to drag this formula down. So it's already being done. But this is seasonality computation. So I have to also compute trend component, whether data has a trend or not, right? For that, I'm going to use a formula called absolute value of correlation. That is equal to ABS correl. Okay, and then take the array and the. So this is the values Jan to July, and this is my timeline for which I'm going to compute the. But the timeline we have to freeze because we're going to repeat this for other item codes. So this is what our trend component. Okay, so this is going to, I'm going to just drag it down. So this is okay. Now, why you have tried to understood whether there's a trend, whether there's a seasonality or not, right? So we have we have a formula called Forecast.ets. So we have to apply ETS. In the formula, there is called a seasonality component. If the seasonality is more than 0 or seasonality is equal to 0. If it is equal to 0, then it is called double exponential smoothing. If the seasonality is more than 0, then it is called triple exponential smoothing. Okay. For that reason, I'm computing the season. I'm trying to understand whether there is a seasonality or whether there is a trend. So we will assume trend as the default factor in the exponential triple smoothing formula. But why I'm trying to calculate the trend component is that whether if the seasonality is 0, if the seasonality is 0, so whether it is good to compute a linear regression formula, whether it good to compute forecasting using a linear regression formula or use double exponential smoothing. So I'm going to compute 2 different forecasting figures if the data has trend component but 0 seasonality component. Okay, so what I have done is now is a pattern. I've understood. I wrote a formula. If I use the if function, I try to understood that if this data contains seasonality or trend based upon these 2 column Q and column R. If contains seasonality and trend, then I will say this is trend and seasonality. If contains only trend and no seasonality, I will say this is trend. So this is all written on the basis of a formula. If you get this seasonality is 0 and trend component is 0.136. So this data is being categorized as trend based forecast. We are going to implement trend based forecast. We're not going to include any seasonality on them. Here, if you look at seasonality is 2 and trend component is 0.034. So we are going to including on our trend and seasonality category. Right here it's 0 and it's 0.173. Trend is 0.173 and seasonality is 0. So what we are going to say here, we are going to have a pattern of trend but no seasonality. So like that, we have made a classifications over here. Okay. So what I've done is I have applied a formula here. If this data is having a trend, then use a linear regression formula. Okay. If this data is having a trend and seasonality, then use the triple exponential formula. Okay, that is the difference what we have done over here. Okay, so let me calculate that for you once again. So if this is equal to trend, then use a formula called forecast dot linear. So this is a linear regression formula. Okay, why we are using linear regression formula? Because we only have one dependent variable, and that is time. Okay, if you have 2 dependent variables, then the linear regression formula will not be applicable. Okay, so let's see what is the target date here. The target date is August 19. Okay, so I'm going to freeze this because I'm going to use the same target date for other item codes as well, right? So now what are the known y's? The y's is the independent variable, and that is our timeline. Okay, and known x's. So the known x's is the timeline. Okay, I'm going to freeze this because I'm going to use the same data for the different other item codes, right? So if you look at here, it is trend and seasonality, it's showing us false. So I'm going to, in order to avoid the false, I'm going to put blank here. So if you see, there is a blank. So for trend and seasonality, it's not going to compute the forecast. It's going to compute only for those item codes which are showing trend, only trend. Okay, so this is what we are getting the response. If you look at the data over here, we have 2 month sales of April 19, 960 and 960. We got a forecast of 397 here. Okay, so there is a huge gap between 960 and 960. But like if you look at, there is a possibility of zero also. In the next fourth line, if you see, that's 810, 1820. Let me only categorize it trend based data. So I'm going to go data and filter, and I'm going to put the pattern as trend. Select the trend. Okay, now let's see. 397. So second data point is, if you look at here, is 285, 195, 2343, 4391, 199, 734 with 2008, and the forecast is 1976. Quite reasonable. Okay, this is how they're using the formula of forecast.linear to compute the forecast. If the given item code and its sales show only trend pattern and there is no seasonality pattern. Okay. Now let's compute for trend and seasonality. Suppose if the given item code shows a pattern of trend and seasonality both. Okay. So what we are going to do with that? Okay. So I'm going to take the filter over here, trend and seasonality. See, I'm going to use a formula now, and the formula is Forecast.ets. Okay. So let me go back to select all. Okay, I'm going to apply the filter. I'm going to write the formula first, then we'll filter out. So if this S2 is equal to trend, you have to write this spelling as same as what you have mentioned in this categorization. Otherwise, it will not work. So if S2 is equal to trend and seasonality, then we are going to use a formula called Forecast.ets because this measures the triple smoothing where we have base, trend, and seasonality. Okay, so that's why we are using this formula. Otherwise, we will not use it. So we will use Forecast.ets when our data shows trend and seasonality along with the base. Okay, the base is already there. So now what we're going to say, target date. Target date is what? August 19. Okay, and we're going to freeze it because this target date will be same for other item codes. So let's put the comma there. Now, so values. What are the values? The historical sales values. Okay, so let's take the historical sales value up to July. Now the timeline. So the timeline is this one. And we're going to freeze the timeline because we're going to use the same timeline for all the item codes. Comma. Next is what? Seasonality. What is seasonality value here? This is a seasonality value. Okay. Now, what is the data completion? So are you going to take the missing values as 0 or we're going to put some other values? So I'm going to missing values as 0 only. And then the aggregation means if you have multiple data for the same time stamp, means like January, you have multiple data points. So are you going to sum it up, take the average, take the mean, take the max? What are you going to do there? So I'm going to take the average. I'm putting 1 there. Okay, close the bracket and 1 more. So here I got it. So what I have to put is, if it is not trend and seasonality, I have to get the blank. So I'm going to put there blank. Okay, so 1749 is the output. Okay, so wherever we have trend and seasonality, we are going to get the responses. So I'm going to take the filter out and put trend and seasonality, and look at, we have responses of forecast for every pattern which has trend and seasonality. So let's compare. Let me freeze. Let's compare these data points. I'm going to let me freeze up to this area. I'll hide this so that we get the comparison easily. Okay, so I'll hide this as well. Okay, Now look at here, we have 2016, 2008, 2008, 2032, 2016, and we have trend and seasonality, and the forecast is 1749. It's quite closer to the values 2016, 2016, right? It's a good forecast. Now it's 1097. 1097 is for 8, 10, 18, 23, and 800, and the forecast is 1097. It's quite close. Right? It's good forecast. So this is how no, this is not the way to check whether the forecast is closer or not closer, or accurate or not accurate. For that you have to measure mean, mean absolute percentage error, then root mean square error, RMSE, okay, mean absolute deviation, MSE mean square error. There are various formulas which you can use to understand whether your forecast is accurate or not. This is how what we have to use. Okay, so the objective of this video was to show you how to use the formula forecast.ets, on which aspects, on which particular pattern you have to use forecast.ets. That was an objective of this video, not to show whether the forecast is accurate or not. So in future we may actually post a video where we will update how to use the forecast functions to compute MAPE, RMSC, MAD, MSC. So just I'll give you a simple hint. You can use forecast.ets.stat. You can use this function in Excel to compute MAPE, RMSC, MAD, and MSC. Okay, that's a simple update which I would like to give you. So I think the video is already long, guys. So I would like to end the video over here. If you have any questions, you can post the questions on the YouTube comment section, or also you can write to us on our email ID, that is krish@mathnal.com, or you can WhatsApp us on our number, that is +917989366381. Okay. So what we would like use, to help us encourage posting more videos, please subscribe our channel, subscribe and press the notification bell. And the reason why we are asking to press the notification bell is because, as moment we post the videos, you should get the update. Okay, once you get the update, you can log in to the YouTube and you can get to know or get to view the content which you are posting on YouTube. Okay, guys. So look forward to meet you again with the new video. So meanwhile, I'll take the break, and this time at India is almost at night. So I'll say good night and take leave from you. Thank you very much for watching the video.